we did refraction from plane surface, image formation from plane surface. Okay. Now let's look at refraction and image formation from a curved surface. Okay. So here we have refraction and image formation okay, from image formation from a curve. Okay, not any type of curve. Okay, we have to study the simple type of curve, the simplest curve. Okay, from curve means spherical, only from spherical. Okay, spherical surfaces. Okay, the surface can be of any type. Okay? In mirrors also we studied only the spherical mirrors. Okay, not any other type. We have parabolic mirrors, we have different elliptical mirrors, different types of mirrors we have. Okay, but we studied only the spherical mirrors. Here also we are going to study only the refraction and image from due to refraction from a spherical surface, curved surface. Laws of refraction remain the same. First of all, the first thing to understand, laws of refraction. Refraction, that is Snell's law. Snell's law, okay, remain the same. It's like laws of reflection. Laws of reflection remain the same for plane surface or curved surface. Similarly, the laws of refraction also remain the same, absolutely same. Okay, for any surface. Okay. Let's look at one general surface here. Okay. Let's say that I have this surface here. Okay, let's say it is a spherical surface. It's a spherical surface. It is going to have some radius. Let's say its radius is r. It's spherical. Let's say it is kind of some material here. Okay, the refractive index is mu2. The refractive index of this material here. Let's say I have this rod-like object. Okay, this is perfectly spherical shape. Its radius is r. The radius of a spherical surface. Okay, and the outside medium, the surrounding medium is mu1. Let's say that it is mu1. Okay. Now this spherical surface will have some center. Let's say that this is the center. This is center of what? This is spherical surface. And this is middle point of this spherical surface. Okay. Let's say that it is P. We can say that it is pole of this spherical surface. But generally we do not use this term pole. It is reserved for mirrors only. Okay, so but anyway, I can say that. Who can stop me from saying? Okay, so it will not be wrong to say, but generally, when we say pole, we refer it to the mirrors only. But that's fine, you can do that. And I have one object here. This is my object. This is radius of this spherical surface. This is pole. Now the line connecting pole is the middle point of this spherical surface. Okay. The line connecting this pole with center, it becomes, principal axis. Object is kept at principal axis. Now, where will be the image? We know that to get image, to locate image, I need at least 2 light rays. Let's take 2 light rays, whichever I find suitable for me, I will do that. Okay. So let me take one light ray, which is moving along this principal axis. Okay. So you see the principal axis is a normal axis. So this axis is normal. Okay, so this light is incident normally on this surface. Okay, it is going to pass undeviated, no deviation. There is no deviation here. Okay, this is my transmitted light. I need one more. Okay, let's take one of the general light like this. A general light. Okay, so this is the point of incidence. At this point, a reflection will happen. Let me find the normal. Very simple. Simply join it with center. That's it. This is my normal. If I simply join it with center, this line becomes normal at this point here. and this becomes angle of incidence. This is the original direction of this light ray. It is going to bend. Okay, depending on medium, this is mu1. Okay, so I have this medium here, it is mu2, the surrounding medium is mu1. Depending on mu1 and mu2, the light is going to bend either towards the normal or away from normal. Okay, let's say that it is bending towards the normal like this. Okay, it is bending in this direction. So this becomes my angle of refraction. This is my normal line, this is normal. Okay, at this point, two light rays meet. Two refracted light rays meet. This is the point where I get an image. And in this particular case, it is a real image. I'm going to get a real image. Okay, do you understand this? Okay, now if this surface, in this particular case, mu2 is more than mu1. I can have a case where mu2 is less than mu1. Okay, do you see? It's like this. I have this spherical surface. It has certain radius. Okay, this is my pole, the middle point of refracting surface. The refracting spherical part. Okay, middle point of the refracting spherical part. This is pole. Okay, and this is going to have its center somewhere. Okay, this spherical surface is going to have its center. Let's say its center is here. This is the center. Okay, and then if I extend this line becomes my principal axis. This is the principal axis, okay, of this spherical surface. Okay, makes sense? Now, my object is kept here. This is my object. This is mu1. This is mu2. This mu2 is let's say less than mu1. So this becomes denser medium. This becomes rarer medium. Okay, I want to locate the image. I will take one light here. It passes undeviated. It is passing incident along the normal. Okay, principal axis is a normal axis. So light ray along the principal axis, it goes undeviated. Okay, it goes to the other side here, refracted. Now I need one other. Let's say that this is the second light ray. Point of incidence, I will draw normal here. This is the normal. Okay, normal. This is the original path. Now this mu2 is less than mu1. Light is going from denser to rarer. It is going to bend away from normal. Okay, it is going to bend like this. That's how the light will bend. Okay, so these two are refracted light rays. They are not going to meet. Okay, but if I extend them backward here, they appear to be coming from this point here. So this becomes my image. This is a virtual image. Now, radius of surface is r, let's say. Okay, now where will the image be? What is the exact location? So we have a relation relating all the given quantity. Okay, all the distances I measure from pole. From pole, this object distance, this is the object distance. This is equal to u. This is u. All the usual signs, usual symbols. This is v, u, v. From pole, we are measuring all the distances. Here also. Okay. This thing here, from here to here. This is my pole. So this thing, this distance, it becomes v, and this distance here, okay, this distance becomes u. Okay. Then how all the quantities are related? Okay, they are related like this. Okay, mu2 over v minus mu1 over u is going to be equal to mu2 minus mu1 over r. Now you have to remember this relation. This is refraction and image formation from a spherical surface of radius r. Okay. The relation, the formula itself is very simple. But when we really start solving problems using this formula, there are certain moments where it becomes really confusing. especially while choosing mu1 and mu2. What is mu1? U and V, we know already. Object distance, image distance. R is clear. Radius of this spherical surface. Mu1, mu2, pretty much clear. Okay, obvious. Refractive indexes of two medium. Now, while choosing which medium I should take as mu1 and which medium I should take as mu2, there is going to be confusion in some cases. Not all the cases, in some cases. And they are the cases which are actually asked in exams. Okay, you know why. Okay. Now, mu1, mu2, they are defined variously in different sources. If you refer to, they are defined variously, okay, not variously, but in 2-3 different ways. But here, let's do it in a manner which is unambiguous, which is there is no scope for any ambiguity. Okay, it's like this. I'm going to write something. You also note down. Try to understand. Okay, try to understand, and then when we really start doing problems, then we will understand the significance of that statement. So for now, just note it down. Mu1 is the medium. Okay, first of all, we apply this. We apply this at the surface where refraction is taking place, first of all. Okay, why I am writing it? It is because in this case there is only one surface where refraction is taking place. Okay, but take this example here. Let's say I have an object like this. This is a glass sphere, and glass sphere. Okay, transparent medium, and my object is kept here. Okay, so this object, the light rays are going to be reflected like this. Okay, several ways it will be refracted. Okay, so one refraction is taking place here, the other refraction is taking place here. Here there are two refractions. Okay, so when I am applying this formula, first of all, I will apply this for the surface where refraction is taking place. Okay, so all the values u, v, r, mu1, mu2, all of them will be with respect to this surface, the surface where refraction is taking place. First of all, okay, at the surface where refraction is taking place, and second, then next one, mu1 is the medium in which incident rays are present. Incident rays, okay, on given surface, on considered surface are present, and not only that, mu2 is the other medium. That's it. Let me write just this. If I write anything more, it is going to be a little confusing. Okay, few things we should take away from this. First of all, object is kept on principal axis, image is on principal axis. Point object, point image. Point object, point image. Object on principal axis, image on principal axis. The same thing that we did for mirrors. Exactly same thing here also. Okay. Now, what if I have extended object? Okay, let's look at that also. Okay, for extended object also, I am going to have the same, exactly same relation. There is no difference at all. Exactly same relation. Okay, let's say that I have this medium. This is some medium, some interface. Okay, it's actually an interface, not a medium, but this thing is an interface which is separating two mediums. What are two mediums? Okay, mu1 and mu2. This is my principal axis for this spherical surface. This surface is going to have some center. Let's say this is the center. Let's say that this is the center. Okay, makes sense? Now, this is pole. Let's say that I have my object here. This is my object AB. Where will be the image? The image of this is going to be on the principal axis. If I just find the image of this end B, I'm going to find the whole image. Okay, let's see. How to find this? I need two light rays. Let's take one light ray which is parallel to this principal axis. One light ray here. It hits the surface here. Now this is mu1 and this is mu2. Now here the reflection is going to take place. It is going to take place here. Okay, this is my angle of incidence. Okay, or let me not write it here. Let me just write. That's it. Okay, incident ray. This is the original direction. Depending on mu1 and mu2, light ray is going to bend either towards the normal, away from normal. Let's take this case that it is bending towards the normal. It is going to pass like this. One light ray starting from B. I need one more. Okay, let me take this one here. Okay, at this point, refraction is going to happen. Okay, this is the original direction. Okay, this angle is I. Okay, now this is going to bend. This was bending towards the normal. This will also bend towards the normal. Okay, it is going to bend like this. It will go and meet here. Okay. What is this? At this point, both refracted light rays meet. Refracted. That means this is image of point B dash. Point B, image B dash. And then I have this image. What type of image it is? The image of point A will be here, A dash. It is a real image. Real inverted. A real image is always inverted. This point we discussed during mirrors. Okay, here also this distance is U. Okay, and this distance here is V. Angle of incidence I. Let's say that this angle is R. Okay, at point P, mu1 sine I is mu2 sine R. Okay. For paraxial rays, I are very small. If I is small, R is of course going to be correspondingly small. Okay, so I can write it as mu1 tan I is equal to mu2 tan R. When angle is very small, sin theta, tan theta, both are approximately equal. Now this becomes mu1 tan I. What is tan I? Okay, it is going to be AB over PA. Okay, it's going to be equal to mu2. Okay, mu2. What is mu2? Is mu2. Okay, nothing to think. Yes, tan R. It is going to be equal to A dash B dash, A dash B dash, and PA dash. This is height of object. This is height of image. Okay. Sign convention. When we did it for the first time, we said that we are going to use it everywhere. Whatever sign convention we have, we have it for everything. Okay. Light rays are going towards right. This distance is going to be positive. This is going to be negative. Above the axis positive, below the axis negative. If I use this convention, then what will be U? U is going to be equal to minus PA. What is V? It is plus PA dash. Okay, makes sense? Now, what is going to be height of object? It is plus AB. What is going to be height of image? Minus A dash B dash. Let's write it here. Mu1 AB, height of object, over PA is minus U is equal to mu2. A dash B dash minus height of image over, this is plus V. Do you see this? Okay. Do you see this? What do I have? Height of image, okay. Height of image over height of object. Okay. Height of image over height of object is going to be equal to V by U minus of mu1 over mu2 V over U. Think about it. Is this fine? Is this fine? If U and V both have opposite sign, here they have opposite sign, then it is going to, the whole thing is going to be positive. No, I think something is not right here. Something is not right. What is not right? AB plus, okay. No, this is not minus, this is plus. AB is HO, height of object. It should be plus here. That means it gets values like this. So it is like this. No minus sign. No minus sign. Just this. This is magnification. What is this? This is magnification. Magnification is mu1. Magnification is height of object over height of image is equal to mu1 over mu2, okay, V over U. That's it. If U and V have opposite sign, that means they are on opposite side of each other, they are going to have opposite sign. So this whole thing is going to be negative. That means this is negative. That means the image will be inverted, and that means it will be real. And it should happen because this is a case of refraction. The light is refracted, the light is transmitted on the other to the other medium. So if there is a chance of meeting of this transmitted light, it is on the other side only, not on the same side. On the same side, it happens in case of reflection. This is a case of refraction, transmission. So if the light rays meet, they can meet only on the other side. When they meet on the other side, that means image is on the other side. So if the image is on the other side, that means U and V are going to have different signs. It is going to be negative, that means inverted, and that's why real. Image is always inverted. Okay? That's it. The same formula is applicable. Now let's do some problems. Let's start doing some problems, okay? Quickly we are going to do it. Locate image. Locate image. The first case. I have this glass sphere. Okay. This radius is, let's say, 10 centimeter. Glass sphere. Radius is 10 centimeter, okay, and this is its diameter. This is the diameter. Its mu is 1.5. Let's say it is equal to 1.5. Object is here at the center. This is my object. So 10 centimeter here and 10 centimeter here. Okay, all right. 10 and 10. One observer is here. Other observer is here. Locate image for both observers. Where will they see the image? Okay. Second, in the same glass sphere, it is the same glass sphere. Here also, radius is 10 centimeter. Okay. 10 centimeter. My object is here. Let's say that this is my object here. My object is here. This is 6 centimeter and this is the remaining will become 14 centimeter. Okay, let's say just for example. One observer is here, the other observer is here. For both observers, where is the image? This is 1.5. Same, okay? Third case. Let's see, this is my surface, okay? This is one interface, is spherical surface. It separates these two mediums. Okay? This is air, and this is, let's say, mu is equal to 2, and this radius is 20 centimeters. Let's say, just for example. And my object is here, and this distance is 30 centimeters. Okay, so 20 centimeter radius, 30 centimeter is object distance, mu is 2. Let's do just this. Only this. We will do more. We are going to do many problems. Let's look at the first problem. First problem. First observer. This is the first observer. First observer. Okay. From which surface refraction is taking place? Okay, let's consider only the first observer, that is on the left side. Left side is observer 1. Okay. This is my object here. One light ray will start like this. Okay. And then there is other light ray here. Now, all of the problems, can you note down? Then you have to stop the video. First, you try to apply this on your own. Let's see what answer you are getting. Okay. Anyway, that's the only thing we are going to apply. There is no other formula. There is no other relation. This is the only thing we have. You do it yourself first, and then we will do it together. We will discuss it together. Then the problem sheet, you will do it alone, and then we will do it together again in discussion. That's how it works. Okay. If I ask you that you can answer this, at least this, I'm not sure about others, but this one, you can answer without even solving it. Without applying this formula, you are going to answer this. If you think a little bit carefully into the problem and the given situation. The object is kept at center. That means this light is already normal. It will pass undeviated. It will pass undeviated. Every light that is coming from this object, it passes through this surface undeviated. Why? Because all the lines are normal. All of them are coming from center. Object is kept at center. That means, what that means? That means for this observer, the object appears exactly where it is kept. There will be no shift. The apparent depth will be equal to actual depth. Apparent depth is going to be equal to actual depth. Okay. So the first we solved without using this, and that is something you have to learn. The moment you see a problem, do not directly jump into formulas. First you think about the problem. In many cases you will be surprised. In many cases problems are solved without even using any formula. But that happens when you really look at the problem and try to understand it. Look at the situation. What are the conditions? What are the data that is given to me? Okay. First think about the data itself. Maybe the data itself tells us many things about the problem. Okay. It's very important to learn this thing. Okay. Understand this? Okay, so first we did already. Second, let's look at the second one. Second, okay. I have two observers. One observer is looking from here, from the left, other one from the right. Let's look at the first one, which is on the left. Okay, so what do you think? From which side refraction will happen such that the observer will be able to see the image or the object? Both are same. There is no difference between object and image. There is absolutely no difference. There is no way to figure out whether you are, okay, there is absolutely no way to figure out whether you are looking at an image or an object. Absolutely no way to figure out. Okay. Think about this thing. Think about this thing. Can you really figure out whether you are looking at an image or the actual object? That is not possible. That becomes possible only when you look from the outside. When you are part of the problem, part of the situation, you will never know. Never ever will know. You know, this is the basis of spirituality. Yes, it is. Think about this. 6 centimeters, 14. Okay, so this is my object here. This is object. Let's focus at the first surface. This is the second surface. Okay. And my observer is here. Okay. So the light starting, you see, from the object, light goes in all directions. Everywhere it goes. We are looking at a simple case. What is the simple case? We are looking normally. I'm not looking at the object from here. When I look at from here, probably I cannot figure out because I do not know how to, like, what formula to apply. Because this is not going to be normal incidence. This is the normal. Both observers are situated normally. They are looking at the object normally. Okay, so I must have added it, but that is assumed by default. That whatever we are doing is for paraxial case and normal case. Okay, we are looking at the object normally. That means my sight, okay, sight is along this principal axis. That is normal. Okay, and then I'm looking at trying to look at this object here. Normal case. Okay. So one light, it starts from here. It goes without deviation. Okay, this light here. Other light, let's say that it hits like this here, one general light. Okay, my center is here. This is my center. Okay, now if I join it with center, okay, at least this will give me an approximate idea of what type of image I am going to get and some approximate location. Now this is a 1.5. Mu is 1.5 and it is going to bend away from normal because it is going to enter a rarer medium. Okay, it is going to bend like this. Okay, so this observer is going to receive these two light. Okay, the observer will see that these two light are coming from a point somewhere here. Okay. This becomes my approximate location for the image. So what it will be? So first of all, look at the formula. We apply this at the surface where refraction is taking place. So I am going to apply this thing at surface 1. At surface 1, refraction is taking place. I will measure all the distances along the principal axis from this point which I am calling as pole. Okay, what will be U? What is U? The light is going towards left. Okay, so this becomes my positive and this becomes negative. The same sign convention we have to use. So U is going to be minus 6 centimeter. Minus 6 centimeter. What is radius? Radius for this surface, 10 centimeter plus 10 or minus 10. For this surface, the center is here. Here is my center. This center is to the right of this surface. I am considering this surface. The center is to the right. That means radius is towards the right. Towards right it is negative. So radius is going to be equal to minus 10 centimeter. Okay, so this U is minus 6. R is minus 10. What is mu1? Is the medium in which incident rays on this considered surface. This is my considered surface. Reflection is happening here. Incident ray. Which is incident ray? This is the incident ray. It is present in which medium? It is present in this medium here. Okay. It is going to be equal to 1.5. And then the other medium. And mu2 is the other medium. Whatever is the other medium is mu2. Okay. So this mu2 becomes equal to 1. It is air here. Air. And that's it. We have to apply the formula. Okay. So mu2 over V minus mu1 over U. Mu2 minus mu1 over R. Mu2 1 over V I do not know, minus 1.5 over U. What is U? Minus 6. Minus 6 is equal to mu2 minus mu1. 1 minus 1.5 over minus 10. Okay, that's how we write and use the sign convention. Okay, so I have this 1 over V plus, it is plus here, 3 over 2, 3 over 12, 3 over 2, 1 over 4, this becomes 1 over 4, plus 1 over 4 is equal to plus 1 over 20. Plus 1 over 20. Okay. What is 1 over V? 1 over V. 1 over 20 minus 5 over 20. Understand this? Not understand this. You see, that's how we solve it. 1 over 20 minus 5 over 20. Minus 4 over 20. So minus 1 over 5. Minus 1 over 5. Okay. That means this V is equal to minus 5 centimeter. This is position of image as seen by this. Minus 5. Minus is towards right. Image is towards right. That means our ray diagram was correct. So this distance will be 5 centimeters. So sometimes it is asked, what is the apparent depth as seen by this observer? The object is located here at 6 centimeters. 6 centimeters below the surface. But when I see it, it will appear to me at a depth of 5 centimeters. Okay, got it? Now, second image here. Similarly, I have one observer here on the other side here. Okay, the light goes like this. It goes like this here. It passes undeviated. Now, one of the light ray I want. I need. Okay, this is my normal, and this is the incident light. It is going to bend away from normal. Denser, rarer. It is going to bend away. It's like this. Now this person receives these two refracted light. He starts wondering where these two light are coming from. Then his mind gets to work. The mind figures out that these two rays are coming from a point somewhere here, it appears to me. Okay, then this becomes image I2. This is where the second person is going to see the image. That means we are going to, okay, let's see what answer we get. Let's see what answer I get. Now, surface 2. Surface 2. Okay. First of all, sign convention. Light rays are going towards right. Okay. So this becomes my positive and this becomes my negative. Positive, negative. Okay. What is U? This distance. What is this distance? This is 14. Okay. U is minus 14 centimeter. What is R? For this surface, its center is here to the left. To the left is negative. So minus 10 centimeter. Minus 10. What is mu1? Mu1 is the medium in which incident rays are present. I am looking at this surface here. For this surface, where are the incident rays? This is the incident ray. It is present in this medium here. Okay. So 1.5. The other medium becomes mu2. That's it. Write this equation. Mu2 over V minus mu1 over U is mu2 minus mu1 over R. Okay. So 1 over V minus 1.5 over minus 14. Minus 14. Okay. Mu2, 1. Mu2 is 1 minus 1.5 over minus 10. Okay. This becomes 1 over V plus 3 over 2. So 3 over 28. 3 over 28. This is minus half, minus 10 plus 1 over 20. 1 over 20. We are going to get this answer. 1 over V. 1 over 20 minus 3 over 28. I'm going to get some negative value. Okay, whatever it is, we have to figure out. Look, like this will be 20 into 28. So this becomes 28 minus 60. Okay, so I'm going to get this negative answer. V 1 over V, or let's say V is minus of, okay, 20 and 28 here over, this is 32. Okay, so you figure out, you have the answer. It will be little smaller than 20. Whatever, that's how we solve it. We solved second one. Okay, let's do the remaining. What about third one? Third problem. Okay, do it yourself. Third one, can you get the answer correctly in your first attempt? That is what is the most important thing. Getting the answer in first attempt. Most important thing. Okay, what is U? Light rays are going towards right here. So this is my sign convention. Positive and negative. Okay, mu 2 over V minus mu 1 over U is mu 2 minus mu 1 over R. Refraction is happening at this surface. I am going to apply this formula for refraction at this surface here. At this surface, incident rays are present here. So this becomes mu 1. Air becomes mu 1 minus 1 over, okay, mu 2. Then the other becomes mu 2 over V. Other medium becomes mu 2. Okay. Understand this. I am not saying that mu 1 is the medium in which object is kept, because that is going to be real confusing in some problems. We will see. You should also note this point. I'm never saying that mu 1 is the medium in which object is present. Mu 2 is the medium in which image is present. No, never ever do that. Okay, you just have to follow what is written here. Stick to this. No matter what resource says whatever the resource says. Okay. Stick with this. You will realize its potential. Okay. U minus 30. Okay. Is going to be equal to mu 2. This is mu 2. Okay. So 2 minus 1 over R. You see, for this surface, its center is somewhere here. A spherical surface, its center should be here, somewhere here to the left. It is going to be negative, okay? Minus 20 here. So 2 over V plus 1 over 30 is here. I have minus 1 over 20. Okay, so 2 over V is minus 1 over 20 minus 1 over 30. This is 60 minus 3 and minus 2. Okay. So this is minus 1 over 12. Okay, 5 and 12 is 60. What is V? Is minus 24 centimeter. Minus 24 centimeter. That means, is it a real image or virtual image? Is it going to be a real image or virtual? Can you figure out? What type of image it is going to be? Okay. Object is here. This is my object. Object and image are on the same side, and this is a case of refraction. In refraction, light goes to the other side. So if I have a real image, it must form on the other side. That means this is a virtual image. Okay, it acts. It's like this. This is 20 here. This is my center. Okay, so one light ray goes like this, undeviated. Another light ray is this. This is the other light ray. This is my center. Okay. Now after refraction, it is going to bend away from. This is this is the denser medium. So this is the light, incident light. It is going to bend towards the normal here. That's how it is bent. It is going to bend. Okay. So let's say that I have this medium like this. Okay. Okay, it makes no difference. Even if I have this medium, I can still apply that. That has to do with the spherical surface. I'm looking at only this surface. At this surface, the refraction is happening. I don't have to bother what is here. Okay? So don't be afraid of by this. It's perfectly fine. Okay, so this is going to meet somewhere here. Somewhere here. Whenever I extend it backward, this is my image. That's how the image will form. Of course, it is a virtual image. Okay? This is third one, okay? Now let's look at few more. Let's look at few more problems, okay? One more. Or let's say, this is the fourth one, it's like this here. I'm drawing this big diagram because I'm going to solve it here itself. This is a problem, but here itself I will solve it, okay? That means, okay, I'm writing, this is the problem. Okay? This is my sphere, and I have here I have this second thing. Okay. Okay, so this is my center here, this is the center, this is center. My object is kept here. Here is my object. This is my object. And this distance is 2 centimeter. 2 centimeter. Okay. This thing here is 5 centimeter. And this is a thing here is 10 centimeter. 5 and 10. And this is the medium. You see? It is air here and air here, and this is medium mu is equal to 2, let's say. You understand what type of situation this is? And my observer is here. This is my observer. Observer is looking normally. Normally means along the principal axis. Observer is looking normally, like this here. Where will he see the object? Where the object will appear to be? Okay, solve it. Okay, can you solve it? And now let me give you one more problem. What is this? A hemisphere. Okay, hemisphere. What is radius? Is 15 centimeter. Radius is 15 centimeter. Okay, and you see my object here. My object is here, is my object, this distance is 10 centimeter and this mu is 1.5 and I am looking from here. Locate the image. Do it as soon as you can. Do it as soon as you can. Let's do it. This is the first surface, this is the second surface. Light starts from here. I want to locate image, I want to find image, need at least, I need 2 light rays. One light ray I take along the principal axis. It passes undeviated, directly reaches the observer. But this cannot form image. I need at least 2. Okay. Let's take one other here. Refraction is happening, it's going to happen at surface 1. Okay, so surface 1. Okay, surface 1. Surface 1. I'm going to write this mu 2 over v minus mu 1 over u is mu 2 minus mu 1 over r. For surface 1, for both surfaces, what will be sign convention? Light is going towards right. So for both surfaces, it is going to be same. For both surfaces, it is going to be same. Light is going towards right. So from this pole, this is the pole here, this is the pole of first surface, this is the pole of the second surface. Refracting surface. Okay, fine. Mu2 and mu1. What is mu2? For this surface here, look at this here. Reflection is happening here. At this surface, which one is the incident light? This is incident light. This is incident light. Okay. Note down these values. I am going to clean it. Okay, make space to draw the ray diagram. To draw the ray diagram. Okay. This is 2 centimeter. This is center. This thing is 2 centimeter. This thing is 5. What is U? 3, minus 3. Mu1, mu2. At this surface, incident ray is present in this medium here, inside this hollow. It is air. It will be 1. Mu1 is 1. Then the other medium, whatever it is, it becomes mu2. So this is mu2 is 2 over V. V I want to find out. I do not know what it is. Minus 1 over U. What is U? This distance is 3. It is negative. So minus 3 is equal to mu2. What is mu2? This is mu2. So 2 minus 1 over R. What is R? What is R? For this surface, R is here to the left. It is going to be negative. So minus 5. Minus 5. Okay. So 2 over V1, let's say V1 is going to be equal to, okay, 1 minus 1 over 5. This is minus 1 over 3. This is 15 here. So minus 3 minus 5. Okay, what do you think? So this is going to be equal to minus 8 over 15. So what is V1? Is minus 15 over 4. So minus 3.75. Okay. Is that correct? Or let me keep it just this, okay? So fine, that's fine. That's perfectly fine. So this is 3.75. This is 3. This thing is 3. So little away from it. It's like this here. Here is the image. That means the light bends like this. That's how the light has bent. Okay. That's how the light bends. Okay. Understand? Do you understand this? Okay. Now what will be this distance from here? Okay. So this is the first image. This first image becomes an object for this surface. Okay, here the confusion arises. Okay, first let me check whether it is right or not. This is minus 2, 2 minus 1, and this is minus 5. So minus 1 over 5, minus 1 over 3. So 15, minus 3 minus 5, minus 8 over 15. Minus 8 over 15. I hope that I am doing it all right. Okay, I'm doing it all right, I guess. So minus 15 over 4, that's it, minus 3.75. I think it's fine. Okay. What? So this becomes an object. So this surface, now for the second surface will think that there is an object here at this location, I1. What will be this distance? This distance here. This distance is going to be equal to, this distance is going to be this whole distance. This is 5. This is 5. This whole thing is 10. This is 5. Okay, so 5 plus 5 plus 5 plus 15 over 4. 15 over 4. This is 35 over 4. Okay, so for the second surface, mu2 and okay, what will be mu2 for the second surface? For the second surface, this is the object. This will be object distance. Okay, what will be u? Minus 35 by 4. What will be mu1? Mu1 is this 1 or it is 2. This is where the confusion happens. Most of the students, Most of the people, they say that this object appears to be in air. So mu1 should be 1. That happens because you think mu1 is the medium in which object is present. That is not correct. mu1 is the medium in which the incident ray is present. Okay. Now this surface knows nothing about this medium here. For this surface, everything to the left of it is medium 2. Okay. This appears to be in air for me because I am looking from the outside. Okay. So this is a case where this is very helpful. Deciding mu1 and mu2. mu1 is the medium in which incident rays are present. For this surface, incident ray is present in this medium. Mu is equal to 2. So mu1 will be 2. Okay. For this surface, surface 2, mu1 will be 2 and mu2 will be 1. The other medium, whatever is the other medium, this is the other medium, it is mu2. So 1 over v2 minus 2 over u. This is u. Okay. So minus 35 over 4 is equal to mu2 minus mu1. This is mu2 minus mu1. 1 minus 2 over radius is minus 10. Okay. So we have this answer. 1 over v2 plus 8 over 35 is equal to 1 over 10. You solve it and you get the answer. Okay, now the next one. Do we have time? Oh, we have some time. Okay, we will do some problems. Okay, next one. Let's do it quickly. Let's do this problem. What do you think? What is going to be answered here? I have one flat surface. This is the flat surface. And this is a curved surface. This is a hemisphere. Okay, it is a hemisphere. It is a hemisphere. Okay. What do you think? How to find it? Okay, so let's change the rays. Let's change the rays. Geometrical optics is all about changing. You change the light rays, you keep on getting everything that you need to find. Okay, so I have this thing here. Let's start changing the light rays. Okay. Let's start making the ray diagram. Making the ray diagram is changing the light rays. This is surface 1, this is surface 2. My object is here. This is my object. Okay. Object is here. Let's say this is my object here. Object. At what distance? This is 10 centimeter. Plane surface. Okay. One light ray passes undeviated. It falls normally, goes inside, comes out without any deviation. That's how it goes. I need one more. Let me take this here. Now, at this point, it is going to deviate towards the normal like this. Okay. So if I have an observer here, to this observer, where the object will appear? The object will appear at this point here. This is the first image. Okay. Now, what will be this distance? It is nothing but apparent distance, d dash, is mu times d, 1.5 times 10, it is 15 centimeter. Okay, 15 centimeter. This r is 15 also, and 1.5. This mu is 1.5, r is 15. Now, what will be this distance? This is 15. Now, for this surface here, this is surface 2. Again, there is going to be refraction. Okay. Hemisphere. So this is going to be centered. Okay. So if I try to figure out where the light ray is going to be, okay. So it is going to be bending away from normal. It is going from denser to rarer. It is going to bend away from normal. Okay. It is going to bend like this. Like this. And if I have one observer here, the observer is going to receive these two light rays. He starts figuring out where they are coming from. They are coming from somewhere here. somewhere here. Okay, so this is where this observer is going to see this object. Now at surface 2, what is u for this surface? So I am looking at refraction from this surface. I will measure all the distances from this point. Okay, this is my image. Okay, for this surface, light ray appears to be coming from this point. So this becomes my object distance. It is going to be equal to 15 plus 15 is 30 centimeter. It becomes minus 30. What is mu1? It is not the medium in which object is present. Then it becomes confusing. You start thinking that this image is present. This image which acts like an object for this surface is present here in air. But this appears to you, not to this surface. For this surface, the light ray is coming from this medium. So this object is also in the same medium. Okay, not in air. That's why this confusion happens. Okay, that's why this is a very concrete, unambiguous way of finding mu1 and mu2. Because mu1 is the medium in which incident rays are present. Okay, so at this surface, incident ray is present in this medium here. So mu1 becomes 1.5. Then the other medium becomes mu2. What is the other medium? The other medium. The light is going in the other medium. So at this surface, refraction is taking place. This is one medium, this is the other medium. Okay, that's it. So mu2 over v, 1 over v minus 1.5 over minus 30, okay, is going to be equal to 1 minus 1.5 over what it is? It is what? For this surface, radius is to the left. Sign convention, positive and negative. Positive, negative. Alright, makes sense? So radius becomes negative, minus 15. So 1 over v. This becomes plus. This becomes 1 over 20 is 1 over 30. We have this answer. 1 over v. 1 over 30 minus 1 over 20. This is 60. 2 minus 3. V is minus 60 centimeter. That means from this point, from this surface, this image is going to be at 60 centimeter. This distance is going to be 60 centimeter. 60. Okay. That is refraction from a spherical surface. Okay. Now solve some problems. Next class, we are going to start doing thin lenses. You see, this also is a lens. What is this? This is also a lens, but this is a thick lens. This is a thick lens. Next class, we are going to start looking at thin lenses. Okay, lenses like this, where this distance is very small. They are thin lenses. This is a lens, thick lens. Okay. To find image from such thick lenses, we have to do it one by one. From each surface, I find image sequentially, successively. Here, for thin lenses, we are going to have one formula where I can find my image in one step. Okay, we are going to do it in the next class.